Welcome to CS 1401 Video 5.2, which is about variables and states. We've seen variables in pseudocode, Java, and Prolog. And in all these languages, a variable is a named place to store a value. So the uses of variable really are two. One, to store a value, and two, to retrieve a value. For example, in pseudocode, if I had a variable called the counter, I could store the value 0 in it. If I have another variable called new counter, I could retrieve the value from my variable the counter, which at this point is 0, and then store that in new counter. So at this point, both the counter and new counter both have the value 0. Now, I want to note that storing a different value in a variable changes the value of that variable. So for example, if I said something like in pseudocode, the counter is the counter plus 1, then whatever the prior value of the counter was, let's say 0, it now has the value of 0 plus 1, or 1. We can implement pseudocode statements like this that increment a variable in both Java and Prolog. In Java, we can say the counter equals the counter plus 1, where equals is the assignment operator. And Java also has a faster way of doing this, which is called a unary operator, and that's just say the counter plus plus, which means increment the counter by 1. And store that value back in the counter. In Prolog, things work a little differently, and I can't change the value of a variable once it's set. So what I'll do is say something like new counter is, which is our assignment operator, the counter plus 1. And I'll remember that in Prolog, all variables start with a capital letter. Now, in the previous video, we saw examples in Java where we had to say what kind of variable it was. So we had variables that were integer types, and we had variables that were float types, or floating point. Overall, a data type is a set of values and a set of operations defined on those values. Java has 8 primitive data types. We've already seen the data types int and float, where int means integer and float means floating point. So when creating a new variable that would be an integer, for example, we specify that its type int. For example, int the counter equals 0. As I said, a data type is a set of values and a set of operations defined on those values. For int, the set of values is the range from minus 2 to the 31st to positive 2 to the 31st minus 1. And you might ask yourself how many bits are needed to store an int. The operations on int are the basic arithmetic operators such as plus, minus, multiply, divide, and so forth. The complete set of data types in Java is int, which is 32 bits, long, which is 64 bits, that's an integer. How big a number can you store with a 64-bit integer anyway? Think about that. Short, which is a smaller kind of integer, only 16 bits, and a really short integer called a byte, which is 8 bits. And there the value goes from minus 128 to positive 127. There are also primitive data types in Java called Boolean, which can have the values true and false. Float, which are 32-bit floating point numbers. Double, which are 64-bit floating point numbers, which means they have much more precision than floats. And char, which is a 16-bit representation of a character, like the character capital A or the ampersand symbol. There are other kinds of data types in Java called reference types, which define things like arrays and other classes. These provide for more complex structures, and we'll look at these later in the semester. Because Java variables have a data type, this protects against making certain kinds of mistakes, such as trying to add a floating point number to an integer. And we already know there are ways to convert values because we saw how we put float in parentheses in our body mass index program. So you can do this if you really want to, but you have to do it explicitly. Prolog variables do not have data types. A variable can take on any kind of value, so you don't have to declare the data type of the variable. Each time a program statement is executed, it changes the program state. Executing a statement might produce output, it might get input, or it might change the value of a variable. So state is defined by A, what statement of the program was just executed, and B, the values of all the program's variables. We care about a program state because this can determine what the program does next. Here are two examples. The first example is calculating body mass index. As we saw in our Calculate BMI app and algorithm, the value of BMI depends on the values for height and weight that the user enters. And in the finding the shortest person in the room example, which we saw a few days ago, the value of the current shortest person depends on all the comparisons we've done. Indeed, in the shortest person example, the choice of what statement to execute depends on the value of a variable. That is, what the values are between the current shortest person and the next person we're looking at. In general, imperative programming languages like Java express these choices using conditional expressions, such as if. And, as you might have guessed, Prolog deals with conditionals in a radically different way from imperative languages. We'll work with imperative style of conditional expressions in next week's class 7, and we'll program a little in Prolog toward the end of the semester. In our next class, class 6, we'll look in more detail at how computers work. I'll see you then.